Hello! This episode is basically the second part of the previous one, so watch that one for some important context. Now, for what's past the Yenyatohs Belt. The sixth planet in the Miriblisk system is Haiblek, the system's largest and most massive planet. It is slightly less massive than Jupiter at 0.9723 Jupiter masses, or 309 Earth masses. That's 93% of all the mass that orbits Miriblisk. It's also about the same size as Jupiter, at 138,829 kilometers wide. Like Jupiter, it is a gas giant with enormous storms and cloud patterns, but these are mostly shrouded by a Saturn-esque ammonia cloud layer, a layer that is thinner and less opaque near the warmer equator. Haiblek also has a tenuous and unorganized ring system of rocky dust. Haiblek's inward migration during the formation in the Miriblisk system is responsible for many of the irregularities in the inner part of the system, as it starved Satiridi and Sierra of material, giving them their small sizes, and it messed with Sierra's orbit. The then closer Zhinpra's gravitational influence stopped Haiblek from doing any more damage. Its orbit has a 6.937 AU semi-major axis, an eccentricity of 0.06, and an inclination of 0.2 degrees. From Bruscelania, it is very bright in the night skies nearly all year long, giving it connotations of strength and gregariousness, and by extension, friendliness, joy, and alcoholic beverages, especially wine. Its large moons are easily visible through a telescope. As a gas giant, Haiblek has an inordinately large amount of moons, 82. 5 of these, Veinme, Nwpdi, Tashda, Aibmiks, and Xich, are major moons. The other 77 are minor. Haiblek also is the holder of many Trojan asteroids. After Haiblek's 6 tiny, fairly unremarkable inner moons, there is the first and smallest major moon of the planet, Veinme. Veinme is a rocky icy moon smaller than our own moon, but bigger than Horisti. It is 3,299 kilometers in diameter and has a mass of 0.0068 Earths, or 0.5525 moons. Veinme is notable for its constant cryovolcanism, making it by far the most geologically active world in the Miriblisk system, but not as active as our Io. This activity is powered by tidal forces produced by the gravitational influences of Haiblek and the other Haiblekian major satellites, mostly the former. All this geological activity lends Veinme its smooth, shiny white appearance, as the surface is constantly rejuvenated by its cryovolcanism. The surface also contains some exposed rock. Underneath Veinme's surface, there are rather warm pockets of liquid water that fuel the volcanoes above them. These pockets would be larger if Veinme contained less rock. Veinme orbits 320,301 kilometers from Haiblek's center, with an eccentricity of 0.009 and an inclination of 0.3 degrees. Following Veinme is Haiblek's second major moon and fourth largest moon, Nwpdi. Nwpdi is also a little smaller than our own moon at 3,430 kilometers in diameter, and it has a mass of 0.0077 Earths, or 0.6318 moons. Nwpdi is a rocky icy moon with enormous, deep, nearly 8 kilometers deep for most of them and 12 kilometers for the deepest point, canyons covering much of the surface. These canyons were formed when Nwpdi's surface expanded as tidal heating warmed its inner layers. As a result of Nwpdi being an icy moon orbiting very close to a large gas giant, as a deep, around 80 kilometers deep, subsurface ocean under its 20 kilometer deep ice shell. In the places where the shell is particularly thin, at the bottom of the canyons for instance, the surface is visibly slightly bluish from the water underneath. Nwpdi is significantly less geologically active than Veinme, but it has a few geysers. Nwpdi orbits at an average of 508,411 kilometers from Haiblek, giving it a 1:2 resonance with Veinme, meaning it takes exactly twice the amount of time to orbit Haiblek that Veinme does, like the relationship between Jupiter's Europa and Io. Its eccentricity is 0.001, and its inclination is, for all intents and purposes, 0. The next moon after Nwpdi is Tashda, a large icy moon larger than Io and smaller than Callisto, making it the third largest moon of Haiblek, with a diameter of 4,030 kilometers and a mass of 0.0113 Earths, or 0.9256 moons. This moon is a two-tone moon like Iapetus, with a surface that's mostly dark red tholins, with large patches of shiny white ice. Tashda's color is so saturated that the moon is visibly red through even a small Bruscelania-based amateur telescope. Tashda has a subsurface ocean like Nwpdi does, although it's a colder one composed of liquid ammonia and solid water slush. Tashda orbits 807,034 kilometers from Haiblek, giving it a 1:2:4 resonance with the two majors further in. The eccentricity of its orbit is 0.0004, and the inclination is negligible. The next moon of Haiblek is the largest of the Haiblekian moons, Aibmiks. Aibmiks is a large moon, even larger than Titan, but not as big as Ganymede at 5,199 kilometers. It has a mass of 0.0230 Earth masses, or 1.8762 lunar masses. Aibmiks is an icy moon not unlike Ganymede in outward appearance, but more geologically active. Frequent cryovolcanism, along with Aibmiks' large size and distance from its planet, contribute to Aibmiks' tenuous atmosphere. This atmosphere, while thin, is thick enough to give the sky a faint bluish color near the horizon during the day, and to support wispy, transient clouds of tiny water ice crystals that descend onto the surface in the form of miniature snowflakes when it gets exceptionally cold. These clouds are also made from the ice from the volcanoes. Like the other moons, it has a subsurface ocean. More precisely, it has two stacked subsurface oceans of water separated by a layer of ice, like what might be under Ganymede's surface. It orbits at 1,281,086 km from Haiblek, placing it in a 1 to 2 to 4 to 8 resonance of the three more inner major moons. Its eccentricity is 0.06, and its inclination is 0.4 degrees. The final and second largest major moon of Haiblek is Xich, which is slightly smaller than Callisto at 4,771 km across, and 0.0212 Earths / 1.7223 moons in mass. This ancient, geologically dead moon is mostly rock with a good amount of iron and ice. Xich's internal structure is only partially differentiated. Xich's surface is covered with craters from 4 billion years of no geological activity. Because of its great distance from Haiblek, Xich has no ocean under its surface, unlike the other large Haiblekian moons. It orbits at 1,901,537 km from Haiblek, breaking the pattern of the major moons being in resonance with one another. It has a remarkably high eccentricity of 0.13, and its inclination is 2.2 degrees. Past the orbit of Xich are 71 tiny minor outer moons, orbiting in eccentric, inclined, and often retrograde orbits, like the outer moons of our gas giants. Also like our gas giants' outer moons, they were captured and formed in collisions between previously captured moons. Beyond Haiblek, there is another more tenuous asteroid belt called the Yenyatohs Belt. This asteroid belt contains many more icy bodies than a predominantly rocky Yad belt. One of these icy bodies is the eponymous dwarf planet Yenyatohs. The belt was formed out of materials left over from the creation of the gas giants. It is a source of several middle period comets that are thrown into the inner solar system by Haiblek's gravity. This belt extends from 9.3 to 12.9 AU. The next planet of the Miriblisk system, Yenyatohs, is an oddity in multiple ways. First, it's the first dwarf planet in the system. Second, it's the closest planet to Briscoania yet to be discovered by the people on the planet due to its minuscule size. Third, it's a dwarf planet directly in between two gas giants. Yenyatohs is by far the largest object in the Yenyatohs Belt at 2,042 kilometers in diameter, a little smaller than Pluto. Its mass is 0.0007 times that of Earth, which is also 0.0588 moons. It has a light blue color owing to copper-based salts being mixed in with the ice covering the surface. The semi-major axis of Yenyatohs is 11.28 AU, its eccentricity is 0.08, and its inclination is 12 degrees. Yenyatohs has 3 minor moons, 2 of which are native to the system, and 1 of which is captured. All 3 are about 10 kilometers across. In addition, Yenyatohs is the largest member of a collisional family with members found all across the Yenyatohs Belt. These members can be identified by their pale blue colors from the copper salts in their ice. This family formed when large impactors threw small pieces of Yenyatohs away from the planet. The next planet in the system, either the 7th or the 8th depending on how you count, is Zhinpra, the final Miribliskian major planet. Zhinpra is an ice giant, much like our solar system's Uranus and Neptune. Zhinpra, as the second largest planet in the Miriblisk system, is slightly larger and a little more massive than both of our ice giants, with a diameter of 52,305 kilometers and a mass of 21.1122 Earth masses. Climatically, Zhinpra has more in common with Neptune, as Zhinpra's thick atmosphere is very stormy and contains the fastest winds in the Miriblisk system. Zhinpra has a large, complex Saturn-esque ring system, formed in the same way Saturn's was formed. Zhinpra orbits 22.56 AU from Miriblisk with a very low eccentricity of 0.004 and an inclination of 1.5 degrees. Because Zhinpra is so far away from Briscoania, it is, for all intents and purposes, invisible to the naked eye, but it was eventually discovered about 90 years ago through a telescope. Because it was manually discovered instead of already known, Zhinpra is associated with traits like intelligence, change, and the arts. Zhinpra has 42 moons, 3 of which, Takusbar, Zhinpumi, and Shattulbretsa, are major, and 39 of which are minor. After Zhinpra's 7 minor inner moons, Zhinpra's first large moon, Takusbar, hardly fits into that category with its diameter of only 377 kilometers, even smaller than Mimas, the smallest gravitationally rounded body in our solar system. Hanging onto the lower bound of spherical hood, it contains a surprisingly large amount of silicate rock and iron, which gives Takusbar enough mass, 0.0011 lunar masses or 8.112 times 10 to the 19 kilograms, to be roughly spherical. Takusbar's interior is not differentiated fully. The moon's low ice composition compared to Zhinpra's other moons is because Takusbar used to be a larger, icier moon until a series of very large collisions removed its outer ice layers. The surface of the moon is very uneven, containing deep cliffs, tall mountains, and large basins. This is because of tidal effects from Zhinpra cracking the moon's surface and causing upwelling of materials from the interior of the moon. This process is no longer occurring because Takusbar's orbital eccentricity is decreasing, causing tidal effects to weaken, and micrometeorite erosion and cryovolcanic activity are slowly smoothing out Takusbar's surface. Takusbar's semi-major axis is 79,444 kilometers, its eccentricity is 0.0002, and its inclination is negligible. To speak of Zhinpra's moons is to speak of Zhinpumi. Zhinpra's second major moon, Zhinpumi, is not only Zhinpra's largest moon, but by far the largest moon in the entire Miriblisk system. At 6,895 kilometers in diameter, it's even larger than our solar system's Mars and the Miriblisk system's Boson and Sierra. Its mass is 0.0586 Earths, better stated as 4.7696 lunar masses. Zhinpumi is so large because a series of complex gravitational interactions in Zhinpra's very early history caused the newborn Zhinpumi to get its own, rather large accretion disk. Zhinpumi is remarkable for another reason. Like Triton, it has a sizable atmosphere of nitrogen. While this atmosphere isn't as thick as Bristolania or Earth's, it's still thicker than Soteria or Mars's. This atmosphere contains stable, long-lasting clouds of tiny droplets of liquid nitrogen. There is another reason that Zhinpumi is notable. Along with Bristolania and Eredev, it's one of the 3 worlds in the Miriblisk system to possess stable bodies of surface liquid. In the case of Zhinpumi, this liquid is nitrogen. It even has a nitrogen cycle, like the water cycle of Earth-like planets. In all of these respects, Zhinpumi is like a larger, colder version of Triton with nitrogen instead of methane and ethane, much like how we thought Triton was until we explored it. Sadly, Zhinpumi does not have life. The parts of Zhinpumi's surface that aren't liquid nitrogen lakes and rivers, these bodies of liquid take up about 1/6 of the moon's surface, are made of solid water ice blanketed by a layer of powdery water ice and sometimes covered by a layer of nitrogen snow. Zhinpumi's land is notably flat due to erosion from the atmosphere and a lack of frequent mountain-creating processes. Craters are rare on this moon, as the atmosphere erodes them and prevents impactors from reaching the surface. Zhinpumi orbits 641,312 kilometers from Zhinpra, with an eccentricity of 0.0007 and 1 degree of inclination. Zhinpumi was the first moon of Zhinpra known on Bristolania, being discovered only a few days after its parent planet due to its great size and albedo. Its name is Verokhachian for Little Zhinpra. The final major moon of Zhinpra is Shattulbretsa, also the second largest. About Rhea size at 1,533 kilometers in diameter and 0.0004 Earth/0.0336 moons in mass, it has a pale yellow-white color from various types of rock contaminating its icy surface, a geologically dead one covered in craters. Shattulbretsa has a bizarre, far-flung orbit with a semi-major axis of 4,100,431 kilometers, an extreme eccentricity of 0.46 caused by some early gravitational perturbations, and an inclination of 19 degrees. Besides Zhinpumi, it's the only Zhinpranian moon known to the people of Bristolania. Following Shattulbretsa are Zhinpumi's 32 outer minor moons. After Zhinpra, the Tazolin Belt begins, the third belt of the system, and the Kuiper Belt of the Miriblisk system. It contains the final 4 dwarf planets, along with millions of tiny icy asteroids. It extends from 29.56 AU, the orbital distance where a body has a 2 to 3 resonance of Zhinpra, to 46.93 AU, the orbital distance where a body has a 1 to 3 resonance of Zhinpra. The first trans-Zhinpranian dwarf planet is Homot. It has a large rocky core, unlike the other dwarf planets in the region. Homot's a little larger than Pluto at 2,399 kilometers in diameter, with a mass of 0.0032 Earth masses or 0.2605 lunar masses, making it the most massive Miribliskian dwarf planet. Homot's surface is given a gray color from the carbonaceous compounds mixed into the material of its icy surface. Homot's terrain is characterized by Miranda-like coronae from a recent period of geological activity driven by radioactive decay in this planet's interior. Homot's semi-major axis is 29.56 AU, giving it a 2 to 3 resonance with Zhinpra, the same relationship Pluto has with Neptune. The planet also has an eccentricity of 0.19 and an inclination of 14 degrees. Homot is currently completely unknown to Bristolanians, and the same applies to every other trans-Zhinpranian object. Homot has 4 moons, a major one named Ibthum, and 3 minor moons. All of them formed at a collision, like Pluto's moons probably did. Ibthum is Homot's only major moon, and it's a rather small major moon at 515 kilometers across, close in size to Enceladus. Its mass is 0.0028 lunar masses, or 2.085 times 10 to the 20 kilograms. It has a similar rocky composition to its planet. Ibthum has a dark surface from the high amounts of carbonaceous compounds on its surface, even more than its parent world. Newer craters on the moon's surface expose the shiny white ice underneath, a lot like Uranus's moon Umbriel. Ibthum orbits an average of 34,890 kilometers from Homot, with an eccentricity of 0.001 and an inclination of 0.1 degrees. Next is the icy world of Ezen, which is the smallest of the Miribliskian planets at only 920 kilometers across, even smaller than our solar system's Ceres. Its mass is a very little 0.0065 lunar masses, or 4.825 times 10 to the 20 kilograms. Ezen has a very unusually brilliant blue color, owing to the compactness of the water ice that makes up Ezen's surface. Ezen's shape is squashed like Haumeia's due to its rotational period of about 6 hours due to a large collision in the past. Ezen's semi-major axis is 32.32 AU, its eccentricity is 0.09, and its inclination is 23 degrees. Ezen has 2 close-in minor moons, one was formed in the collision that gave Ezen its increased rotational speed, and the other was captured. The penultimate planet is Frij, the largest dwarf planet in the Miriblisk system at 3,203 kilometers in diameter, a little smaller than our moon, and much less massive, 0.0027 terrestrial masses, or 0.2217 lunar masses, due to its composition of mostly frozen water, ammonia, and methane. Because of its low density, it's less massive than Homot. Frij's surface looks a lot like Pluto's, having a similar pale brown color to the tholins on the surface. Frij's semi-major axis is 35.81 AU, giving it a 1 to 2 resonance with Zhinpra. Its eccentricity is 0.31, and its inclination is 7 degrees. Frij has 7 moons, one of which, Frijlet, is a major moon, while the other 6 are minor moons, 5 natural and 1 captured. Frijlet is the sole Phrygian major moon, but calling it a moon may be a bit of an understatement. With a diameter of 2,018 kilometers and a mass of 0.0009 Earths, or 0.0737 moons, 63 and 33% of Frij's diameter and mass respectively, Frijlet's relationship to Frij is like an even more extreme version of Charon's relationship with Pluto. Frijlet is essentially a smaller version of its parent world, with a very similar appearance, size, and composition. Because Frijlet is so large compared to its parent, it doesn't actually orbit Frij. The two actually both orbit a barycenter 6,494 kilometers from the center of Frij, a barycenter that the minor moons also orbit. Frijlet's center orbits 94,533 kilometers from the barycenter, with an eccentricity of 0.0001 and essentially 0 inclination. The final planet in the Miriblisk system is Fixta, which is smaller than Pluto at 1,949 kilometers in diameter and 0.0009 Earth masses, or 0.0765 lunar masses in mass. It is a deep dark red color from the variety of tholins on its surface. Fixta is very heavily cratered from its historical lack of geological activity. Fixta has a set of dark dusty rings from a large, somewhat recent collision that scattered material in the Fichtian orbit. Fixta's orbital distance is 46.93 AU on average, putting it in a 1 to 2 resonance of Zhinpra. Its eccentricity is 0.35, eccentric enough to carry this far-flung world about 16 AU past the edge of the Tazolin Belt. Its inclination is an extreme 43 degrees. Fixta has 3 moons, all of which are minor and native to the system. Past the orbit of Fixta, the Miriblisk system continues mostly in the form of various icy asteroids and other small bodies, all the way to the edge of the star's gravitational influence, where you will find the Ipsako Sphere, a gigantic, roughly spherical cloud of comet-like bodies surrounding the system, like our solar system's Oort cloud. Here are some size comparisons of the bodies in this video, as well as in the last one. To conclude, I find it necessary to say something that I should have said in the last episode. Whenever I give the name of an object that the Bristolanians are yet to find, the name it's given is the name they will give it when they do find that object in the future. If I didn't do that, this video will be even more confusing. Also, keep in mind that the Miriblisk system is an entire solar system, so I can't mention everything in it. I'll probably make another space-related episode eventually to address some of the other things, and also because I really like space. I think the next video will be about Bristolania's early history. Anyway, I hope that you enjoyed this video. Goodbye.